Okay. Yep. So once again, if you, I mean, no, once again, I just started the video. Anyway, so this video or this session is gonna be about Linux disk management slash how to do partitioning stuff and what is LVM and a whole bunch of switch stuff and yeah and possibly something more depending on how long this video is gonna be. But I'm gonna try to make it as brief but as deep as possible. But can't really go too deep here, you know. Um, but yeah, so let me go ahead and log into a Linux server that I spinned up on AWS. And if you don't know what AWS is just a cloud provider. And if you don't know what the cloud is, technically this is not about it, but since I'm still about to log in, I can go ahead and explain it real quick. The cloud is basically you need some you know computing service. You need a server, you need a load balancer, whatever you need, but at you don't have the expense, you don't have the money, or you just need to borrow it from someone, right? And borrow as much capacity as you need and pay as you use or as you go, right? And basically these companies such as Google, Amazon, and Microsoft and Linode and so on can provide it to you, and pretty much you pay as you go. That's it's much deeper than this, believe me. But I'll just try to explain it as quickly as possible as I am logging into my account, so I can go ahead and spin up a server. Give me 1 second here. Okay. Alright, so let me go ahead and go to the EC2 and spin up the server so we can start working. Okay. Alright, go to launch instance. Of course, you can use a server from wherever. It doesn't have to be AWS, okay? Um, let me just call this what? Let me just call this. Let me just call this what? Just call this test. Alright, and then I choose my AMI. Let me just go Red Hat. Free. So again, you don't have to do this because, and you might have to pay for this depending on other stuff. You don't have to do this. You can use Vagrant, and if you're watching this video and you've been with me for some time, you should know how to spin up a server anyway from Vagrant. So again, you don't have to do this. So got my security group looking nice there. Alright, for the sake of this video, let me go with 4 of these. So these are pretty much I'm adding 4 hard drives. So like an actual hard drive to the server, you know, and should be good enough. Alright. Apparently the server should be accessible and see pending. Let's give it a second. Yep, in the meantime, let me make sure I'm in the folder that has my key pair. And it's not a cloud session, so I'm not gonna go ahead and teach cloud really. I actually gave too much explanation on cloud, to be honest. Um, I just personally prefer using um, um, a cloud and EC2 to do these things, because with Vagrant, especially teaching about hard drives and so disk and partitioning and stuff, doing that with Vagrant is a bit weird, or at least me personally, I find it a bit weird. I haven't been able to because you have to like edit the vegan file, do all the setup up and down. But with AWS, as you can see, it took me what, a minute or two, real fast, you know, and and I understand that I might have to pay some money, but it's cool. Okay, so let me go ahead and SSH into that server. Again, I'm not gonna explain basic stuff anymore, because if you're watching this video, I'm assuming you've watched my previous videos and you've been with me for quite some times, or I mean, yeah. So I'm not gonna explain what SSH means and stuff. You should know that by now. Okay, so I'm into the server. So before I get here, let me go ahead and explain, give a quick explanation about disk management, or what does it partition even means, or LVM and stuff. And again, to be quite honest with you, it's a concept that I'm even still um, studying or understanding to this day. So I will advise you to, even after this session, to go on YouTube or any elsewhere if you didn't fully understand, or just advise you, just like any engineers really, go and get more information about this. You remember, you're an engineer, so I shouldn't even have to say anything. You should know this by now. But anyway, so let me go and do this quick explanation. Let me. All right, so here is a hard drive, right? So here is a hard drive. So so you have your hard drive. Just like any computer, right? When you buy a computer, you say, okay, so I want 8 GB of RAM. Okay, I'm looking for something with a lot of storage space, right? That's what we call a hard drive, right? And yeah. So let's say this thing is 10 GB, right? So this hard drive that is in your computer or your server is 10 GB, right? And pretty much there's something called a partition table, right? And again, this is something that it would take quite some time to really go too deep into that, but just think of it as the the technique, or the conventional way to partition or to work on a hard drive. So what do I mean is, technically, if you have a hard drive, think of it as a piece of bread, right? Um, you Before you do partitioning, which partitioning pretty much means this. Partitioning means, you cut this thing in as many parts as you want, right? One, two, right? And then let's say we have this big space here, right? So we cut this thing into three, right? So we can say, we can definitely say that this is 5 GB, this is 3, and this is 2 GB, right? So it's still a hard drive of 10 GB, but we divided it into three, right? So we have three partitions, right? And before you partition a hard drive, before you cut the bread into multiple pieces, right? You have to set the partition table, and I'm going to show you how to do all that, right? Um, and today's partition table is called G. Yeah, okay, this is awful. GPT. And again, if you want to go deep into understanding what GPT or whatever, and what's even partition table convention or name means, you can do so, right? But honestly, you don't need to go that deep. All you need to understand is that before you partition a disk, or a hard drive, you need to set the partition table. And nowadays, on today's servers, especially with the Red Hat family, the partition table convention that we use is called GPT. Before this, it was called MVR. And again, if you want to go deep into this, you can go ahead and do your own personal research, but you don't really need to know all the nitty gritty about this. Just understand that before partitioning, you need to set the partition table. So pretty much, the partition table, it defines how do we partition this hard drive, right? But like I said, nowadays most servers or today's servers are gonna be GPT, right? And if it's not set, you want to set it to GPT. So, and we're gonna definitely, I'm gonna show it to you on the command line in a minute, right? So here it is, right? So first step, I set my partition table to GPT, right? And then I go ahead and partition. So I cut this hard drive into pieces, right? Three partitions. So one partition with 5 GB, one with 3 GB, and the other 2 GB, right? Okay, so let's go to the command line and do just that. All right, so you remember, I'm pretty sure you remember this command, right? ls plot. And let me get my screen a little bigger. Okay, there you go. All right, so actually, let me clear this here. So pretty much to list the hard drives of a server, you do on Linux anyway, ls block, right? lsblk, right? So what does this do? It shows you the list of hard drives and other things, the list of hard drive with their name, the size, their type and their points. And I'm gonna explain what all these are, right? But let's go with the names first, right? So here we have 1, 2, 3, 4. According to LSBlock, this server has 4 hard drives connected to it. And I'm gonna tell you why I'm not reading this. Don't worry, these are not hard drives. I'm gonna tell you. Right, so we have 4 hard drives. So we have 4 disks connected to this server, right? So, and again, if you're kind of brand new to servers, right? So again, it's just a computer, right? So just like your regular Windows or whatever, right? You have 4. If you connect 4 hard drives, right? To that computer, right? And then you go to check the list of hard drives on the computer, whether it's Windows or Mac, you will see 4 hard drives, right? Just like here, right? But with Linux servers, you do lsblock to list them, right? Now, what is this? Remember earlier when I was telling you about the oops, where did that go? Let me get back to, there you go. Remember earlier when I was telling you about, partitioning, right? Meaning partitioning is you have a hard drive and you cut it into multiple pieces. Um, and you, of course, you choose how many pieces you need, right? So how many partition you want out of that drive, right? That's up to you. So what happens here, as you can see here, this hard drive, right? This disk has been cut into 1, 2, 3, 4 parts, right? So this hard drive has 4 partitions, right? And another way to know, I mean, you can clearly see the tree here, right? Meaning these come from this. That's why we have this tree looking, right? And it even tells you here when you see the type, right? It says that this is a disk. So this is the nature of this thing here, right? And it says that this part, right, or partition. You see what I'm saying? And you can even see that judging by the name. You see XVDA, XVDA1, XVDA2, XVDA3, and so on, right? Um, so that's how it works, right? And then you see here XVDB, which you see the type, and you don't see any tree here. So just telling you that these 3 here apparently they don't have partitions, right? So these here have not been cut into pieces, right? And as you can see here, all these partitions or these parts or these pieces of this drive have a particular size assigned to them, right? And of course, they're on this bread, just like the example that I said. If this hard drive is 10 GB, right? Do you think we can have a piece of 20 GB? That doesn't even make sense, right? So same thing here, right? Meaning out of 10 GB, okay, you would be 1 MB. You would be, depending on whatever you want to do here, right? And I'm not just gonna give you explanations about this. We're gonna do something, here, and you're gonna fully understand this thing, right? So now that you get that part, let's go ahead and create a partition, right? Okay, so another command that I want to show you, and this command is going to be very useful. So when you do ls block, um, you do ls block, right? I already told you what ls block does, right? But there's another command that also shows you a little bit more. So f disk dash l, boom, and don't let all the numbers and scare you or whatever. Stay calm, okay? Don't let the terminal scare you. Stay calm, breathe, and pay attention, especially to the boldness of certain words, right? First line, you see this here. Okay, so let me just tell you how this command works. So you see the first disk, second disk, third disk, and fourth disk, right? You remember these? You remember these names? XVDA. You remember these, right? When we did the ls block, you remember seeing that earlier, right? You see? You remember the size? So it's the same thing, right? The only difference now is that it shows you something. It gives you a little more details and stuff. For example, it shows you the disk identifier, and we will talk about this thing in a minute. So this, think of this as like the ID of this disk, right? And yeah, the ID of this disk. So remember earlier I told you about the partition table, right? And hopefully you remember what I told you about that. If you forgot, just go back into the video and rewatch that part. So as you can see, remember what I told you, right? And see, I didn't do anything here. I didn't set anything. I didn't do anything. I just you saw me. I didn't set anything, but you can see disk label type GPT. Remember what I was telling you earlier, right? That nowadays servers are coming set up with GPT, right? And you might be wondering, so who did the partition? Well, why is this thing partitioned? Is it naturally partitioned, and why are these not partitioned, right? So you need to understand that for your computer to boot, right, it needs it takes some storage from your hard drive, and this is not just a Linux thing, anything, Windows, whatever, right? So when you buy a computer and it say let's say for example, let's say the computer is 100 gigabyte of storage, right? You boot the computer for the first time, you log in for the first time, boom, you go into your computer, you check, it's not gonna be 100 gigabyte free space on the hard drive. You know that, right? It's probably gonna be what, maybe 89, depending on the size of the operating system, which operating system we're talking about, and if while you were booting it you install some stuff and stuff like that, right? So yeah, so just like any other computer, the computer is gonna use the some storage space for the booting, right? And it's gonna be partitioned in some kind of way, because some, like for example, this partition here is the type, for the boot AF system, and we're gonna talk about file system in a minute if we have time, but just to tell you why you're seeing that partition. And even when you do ls block, you can see here, right? So the root, and again, I'm not going to explain what is the root. If you're watching this video, you should know what is root, right? So you can see the root is assigned a partition by itself, right? And it has quite pretty much the most part of this hard drive, right? Another part which goes for the boot, which I mean, obviously, this is where most of the files or most of the things that the computer needs to boot stays at, right? And so on, and apparently this is not even mounted on anything, but yeah, I guess you can call this free space. But yeah, so that's the reason why you're seeing that like that. So now let me go back to disk, fdisk dash l once again. So fdisk dash l, just like ls block, shows us the four hard drives, right? So here you can see that when you would do partition, when you partition this disk, right? So this hard drive, you will see the list of the partitions right under it, right? Just like here, right? Just like here. showing you the start, meaning so on the 10 gigabyte of this hard drive, when does it start, the eating off the hard drive, right? And usually it will start at least 1 megabyte. You can't just, that's why you see start, and you don't really have to worry about all that. You just have to remember how much space do you want that specific partition to eat off of the hard drive, right? Okay, so let's move on. All right, so let's go ahead and create a partition from who. Let me use fdisk again. I like fdisk because it shows you the path to the drive. Okay, so let's work with this hard drive here, right? XVDD, and apparently it's 8 gigabyte. You can see here when you look at the information compared to here, for example, right? You have the unit, but you don't see the disk label type. You don't see it here, right? This tells you what? That this doesn't have a partition table set. If not, it would have showed you a disk label type or partition table type, right? So, of course, before we create a partition, we need to go ahead and create a partition table. Okay, so now what we're going to talk about, some the command to do it. At least one of the commands, or the easiest and most used command nowadays, is what we call the parted command. Parted command, and I'm going to show it to you right now. So let's go ahead and copy this path. Yes, you need to have this path or memorize it or whatever, right? This is the path that we want to work with. This is the disk that we're going to create a partition from, right? So let me clear my screen. So you do parted, and you put the path to the thing. Parted, the parted command. Boom. So the parted command, it's an interactive command, meaning we are in the parted command right now. So, for example, let's say you don't know what to do. It's just say help. I mean, it says it here. Type help to view the list of commands. Right? Help. Help tells you what. So what are we trying to do? We're trying to create a partition, right? But before you create a partition, we have to set the partition table, right? Okay. Let's read here what command will help us to set the partition table, right? Print. Oh, here we go. Create a new disk label. Partition table. That's the same thing. Okay. What is the command? mk label mk table, and then followed by the label type. In our case, I already told you we're going for GPT, right? Okay, so meaning we can use any of these two commands and followed by the label type. Okay, cool. Let's do that. mk label GPT. Boom, it's been done. And how can we verify that whatever we did has been done? There's something called and remember, we're still inside the parted command. It's like I said, it's an interactive command, right? So if you want to see the details, you remember earlier when I did fdisk space -l, I was seeing all the details regarding the drives, right? So if you want to see the details of the drive, after you did something, or even whenever you want to see them, right? While you are in the parted command, you do print. It even says it here. Okay, print. You can say print and then specify the device or whatever, but in this case we already specified the device all the way here, right? That's what we're working on. So print. Okay, as you can see, it shows us the size of the disk in megabyte. Okay, cool. Oh, there you go. See, partition table GPT. So it finally has a partition table assigned to it, right? Okay, so let's quit here. So let's get out of the parted command. So I want to show you something else, right? And how do we do it? We simply say quit. Boom. Let's clear the screen. Let's do fdisk -l once again. Okay, so we're working on this, right? Do you see? This label type GPT. And now do you see it has a disk identifier? These two lines weren't here earlier. You remember, these two were not here earlier, right? So this is what happened when you create a partition table, right? And as you can see, these two other disks, they don't have a partition table, right? So if we do whatever we just did with the parted command to these two here, right? This and this. These two lines should be added, right? So now let's go ahead and create a partition. I just wanted to show you guys that. Okay, so still we need to use the parted command. Parted, and then we put the path to this that we want to work on. Boom. Okay, how do we create a partition? Okay, I don't know, right? Let's say help. Let's say help. Oh, here you go. Make a partition. Easy, right? What's the command? Oh, the command is make part, the part type, so the partition type, fs, so it's called file system type, star, and you don't need to actually write all this. Just let me just show you. This will be the fastest way to do it, but you don't need to do that actually. You can go step by step, right? Let's go step by step. Okay, so we already know the command. M part, mk part, I'm sorry, mk part, and then actually you don't need to put the part type. You can just say mk part. Boom. Partition name. Okay, we can call it whatever we want. Say test demo. Yeah, let's just call it. Boom. File system type. Just put XFS. Well, and again, file system in itself is a whole session. It's a whole video, and it's something that can be really tricky. So I will advise you to go on, anywhere on YouTube, or wait for the next video that I will upload explaining this subject. But I can't really go into it right now because it's kind of tricky if you don't even understand disk management yet. It's a whole nother subject in its own. But one thing I would tell you from my work experience is that most Linux servers, for companies anyway, go with XFS, but it's not a standard thing. It really depends on how you guys work. But in any case, let's put XFS for the file system, and then start. Start meaning on the size of that disk. Where do you want this partition to start eating off of? And the first partition, you always want to start with 1 MB. So start on, and you know what, it's better if I explain it with the whiteboard. There you go. So let me delete this circuit. Man, I did not mean to do it. Okay. Okay, so remember, the disk is a bread, right? Big piece of bread. And so let's say I'm cutting this piece of bread in two, right? Two, and this thing is 10 GB, right? Okay, so first partition that I'm creating, so this space here that I'm creating, right? Alright, so of course it's gonna start from, let me go into this. It's gonna start from somewhere to somewhere, right? Meaning, and then like I told you, you don't put, when say start, you don't put 0 MB or 0 GB. You start with, it always starts with at least 1 GB. So as you can see, it's gonna tax. So when you do this partition thing, it's gonna tax. It's gonna eat off of the hard drive a little bit, like taxing you. So we're just gonna say we need this partition to be from this to this, right? So let's call this, obviously, if this is gonna be 2 part of 10 GB, this is gonna be 5 GB, right? So this is gonna be 5 GB. 5 GB right here, right? So of course this here is also going to be 5 GB, right? But this goes from 1 MB, right? This goes from 1 MB to what? For this to become 5 GB, right? Or let me not even get into conversion of megabyte to gigabyte, not to confuse you or whatever. But yeah, so this starts from 1 GB. Yeah, let's go with 1 GB, right? For this to become 5 GB, we have to stop at what? We have to stop at 6 GB, right? And please let me know I'm not doing this math wrong. But yeah, because in between this, that's when you have 5, right? Hopefully I'm not getting ridiculous here, but anyway. So for the other 5, so this other part here, right? This other part here, we're gonna go from what? We're gonna go from 7 GB to what? To 10, since the whole thing is 10 anyway, so we can go beyond it, right? So, and again, maybe I'm even wrong on the math here, but this just to tell you, we started with 1 and then 6, so from 1 to 6 is already busy, right? So the next one is going to be what? 7 till the end, right? So till 10. So if you do it in that sense, then it's going to be 7, 8, 8, 9, 9, 10. So this is actually going to be 3. So yeah, so the math is actually wrong. So it's going to be 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So yeah, so and again, it's gonna tax a lot of the megabyte and kilobyte here, you know, and this is just a funny way of explaining it. As long as you understand the concept, really, the math here doesn't really have to be completely correct, because when I do it here, I know exactly what I want. So, for example, on this 8 GB of disk, um, let's say we want this partition to be 2 GB, right? And of course, you should know that 1,000 MB equals 1 GB. You see what I'm saying? So we say start at 1, and since we want what, 2 GB, right? And at 2,000. But hold up, it's not actually. But this, if you really count it normally from 1 MB to 2,000 MB, it's not actually gonna do 2 GB. You want to know that it taxed from 0 MB to 1 MB. So that's 1 MB that's going to be taxed, right? And you want to assume that it's going to tax another megabyte just in case. So let's put 2 MB here. Actually, let me just put 1 extra MB here, and you understand what, right? So I say print to see the information of this. Oh, aha, there you go. Here's the thing, the partition we just created called test demo file system XFS. You see, size 2,000 MB, so 2 GB exactly. Now, if you remember, if I did 2,000 MB here, it wouldn't have say 2,000 MB full size, right? Because, like I told you, the system is gonna tax uh, um, part of the hard drive. That's why you start at 1. So I added 1 MB here on the end because we started, because I understand that, from 0 to 1, that's 1, right? That's 1 MB that's been taxed, right? So I'm adding it here, so I'm sure that it's going to be actually is actually going to be 2,000 MB. And again, hopefully that makes sense, because it makes sense in my brain when I do the math like that. So however this math is done in your brain, as long as you understand the way we eat off of this hard drive, you're good, right? So there you go. We went ahead and created our first partition. Congratulations, you went ahead and created your first partition, right? We called it test demo. We assigned a file system called SFS, and the size of this partition is 2,000 MB, so 2 GB, right? So we are done creating the partition, so let's quit. Alright, we got out of the party command. So let's do the fsdisk again to see it in a more clear way. What's that disk? Oh my god, so many words, so many numbers. Okay, here's the disk that we're working on. We assign the disk partition, the partition table, and boom, here it is. You see, and now that you do fdisk-l, you see how it kind of started eating off, you know, 1.9 GB. It's not actually showing 2 GB. That's what I'm saying. It's you have to kind of play around with the megabytes and stuff. But yeah. So we went ahead and created a partition. So now let's see it with the ls block command. Ls block. Boom. Here it is with the ls block command. Right. So let me do something here. Okay, so as you can see, we have it down here. Let me put this thing on the side. Okay, so there you go. With the ls block command, we can see now the drive has a partition, right? See the type, part, 1 GB out of the 8 GB. So you just created your first partition. Now, remember why we create partitions, right? So you don't want to assign a whole, and this is the point where I need to talk about mounting, you know, and mount points. And for that, for that talk, we need to learn about this other command called df-h. So df-h shows you all the places on this servers that have that are mounted on a partition or a a partition or a something that we're gonna learn in a moment, a logical volume or volume. So basically, what does that mean? It means that so for example, let me do ls, right? Okay, close it. Let's go to the root, right? Cd root. Let's say ls, right? Let's say ll, right? So you know that in Linux, everything in Linux is a file, right? A directory is a file is a file, everything is a file, even commands are files. But that's a little too deep. But just let's say, for example, for the directory called home, you say, okay, home, I want home to only, so you want to dedicate a specific portion of your hard drive to a specific part of your computer. And let me go back to the ls block command to df-h here. So here, let's come to what? Let's take this, right? Mounted on. So we're saying this drive or this partition or right this space here, which is 9.5 gigabyte, is mounted on this file, so this part of your computer, and this is the root. So meaning for root, so for this specific folder of this computer, this is the size of the disk that has been assigned to it. And currently, as you can see the word use here, currently it's using 1.2 of this partition or this drive. So, so out of the 9.5 gigabyte, this is 1.2 is being used, and 8.2 gigabyte is available. So you can say ls block. You can say, okay, out of this drive, the DD, right, which is 8 gigabyte, I want to make sure that 2 gigabyte out of this is assigned to the home directory, for example, any file or any folder, right? So I want to assign that specific portion of the hard drive to that specific part of my computer, right? And that's when you create a partition to do that. And that's pretty much what mounting a drive means, right? You assign that specific disk space to that specific place or directory, right? And that's what's been done here. And if you know the file system, or not, if you know the way, the pyramid of Linux, pretty much everything is on the root, right? So according to df-h, root, which is pretty much where everything is located at, has 9.4 gigabyte assigned to it, and this is the partition that possess that space. You see what I'm saying? And apparently within root we chose specific part of this computer and we assigned them to specific partitions with a specific size, right? So you won't be able to go beyond this size because this is, we assign the specific space, the specific size to that specific place. hoping that you will not go beyond this because you cannot, right? And also, that's another subject called quota. We're gonna see that another day. But let me do something very nice here, right? So let's go ahead and now that we understand what partitions means, now we understand how to create a partition, we understand what a mount point is. Let's go ahead and create a, let's go ahead and mount something to something, right? Um, Usually, you see some people, as you can see here, for example, right? You can see the partition has been mounted to the mount point, so to the folder or directory, right? But actually, that's not. I mean, you can do that, but the I would say the more secure way or more organized way to do it, instead of mounting the actual partition, you do something called um, logical volume. And this is the part where I need to give you a brief explanation of what LVM means. You know, so let's go see the definition of LVMs. Um, definition definition of LVM. Please forgive my Mac being slow. Okay. Yeah, I definitely need a better computer. Anyway, so so LVM stands for logical volume management and is a form of storage virtualization that offers system administrator a more flexible approach to managing disk space, right? Um, Meaning it's pretty much the way we view space in a server, right? The way you can view and understand how space works, right? So by space I mean storage, right? And here you have a bunch of diagrams, to kind of give you a visual understanding of what um, logical volume is, right? And whatever diagram works for you makes you understand this better, then fine, use that, right? Um, I'm gonna go ahead and explain it to you, and you can go ahead and choose whatever diagrams works for you, right? But the three things I'm gonna teach you, right, to so that you understand and you know how to do. But first, let's see this diagram here. And again, if you don't understand this diagram with my explanation, you should be able to understand the concept and do the thing anyway, right? So, but I think this diagram is pretty. It's actually pretty easy, pretty simple, or pretty accurate to what LVM actually is, right? So let me go ahead and so the three concepts of this LVM thing, right? We have physical volume, volume groups, and something called logical volume, right? Remember, LVM is just the way we visualize space or storage in a server, right? So it's not a thing, you don't go in the server, hey, let me find LVM. Is think of it as a concept, if I can say like that, right? The concept of disk management, if you can say like that, right? So we have a hard drive, this is a hard drive, right? And out of the hard drive, we create a something called physical volume. So, you know, we can get into the nitty gritty of physical volume and the definitions, but I find it to be sometimes a little, it took me some time to even understand what that means, and sometimes in Linux or engineering, and sometimes going into the deepness of something isn't really going to help you understanding it, sometimes you just need to understand the concept, that's it, especially when it's not something that is actually going to affect the way you work. Just understand the concept and move on, you know what I'm saying? So this volume, you can read the definition if you want to get into, you know this dictionary stuff, right? Here it is right here. But the disk volume, think of the disk volume like the socket where you put the hard drive. That's the way I think of it. It's probably not even that. But when we get into doing actually on the command line, you understand that you didn't actually need to understand the dictionary of it, really, the concept. As long as it makes sense in your brain, you can actually move on, right? So you have the physical volume. This is where you put the hard drive. Let me turn up this computer here. It's a bit loud. Right, so you have the physical volume. This is where you kind of like put the hard drive. It's like the socket where the hard drive is kind of stays at, right? And then you need to create volume groups. Volume group, it's like a pool of physical volumes. So think of volume group as this. Wow, that computer was really loud, man. I took it away and it's like quiet. Man, I'm so sorry. Hope you were able to hear everything I said earlier. Um, Let me erase all this. Okay, so so think of volume group as just like it's called volume group, right? So you create physical volumes, and like I said, physical volumes is just a socket, right? Meaning box where you put your hard drives. So we have one physical volume, two physical volume, three physical volume, four physical volume, and so on, right? And and I really don't want to be wrong with this, but you can actually have give me 1 second. Let me double check something here. Mm, all right, so so these are physical volumes, right? And each of these have a hard drive, hard drive, hard drive, hard drive, hard drive. What a what a what the let me create this here. What the volume group is pretty much, hey, I have a bunch of physical volumes, meaning a bunch of servers in their sockets, right? We need to put them in a group. So a bag. So in that bag or that group we call it the physical the volume group. So boom. So within a volume group you have one or more physical volume. So this is the volume group, a big bag full of physical volumes. And physical volumes pretty much is hard drives or drives, right? And hard drives or drives meaning the partitions of hard drives. You see what I'm saying? So actually one partition, one partition, one partition, or just the disk itself. So you have a volume of yeah, volume group, and you're like, okay, cool. I have volume groups where I grouped all my you know disk, or I grouped all my partitions, right? Now you say, okay, I want to assign a particular piece of the 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 gigabyte, the space, to a specific part of the server. So this is the mounting process, right? Remember this mounting process, right? And again, I'm really trying to make this not complicated to understand, because it really isn't, or I actually could be, but yeah. So let me go here and actually give you guys um, data so you can kind of understand this. So this physical volume is 2 gigabyte. This physical volume is 2 gigabyte. This physical volume is 2 gigabyte. This physical volume is 2 gigabyte, and this physical volume is 2 gigabyte. So we have 4, we have 4, that's 8, and we have 8, 9, 10. So we have 10 gigabyte inside of this volume group, right? So since the volume group is the bag that contains all those physical volumes, how much is the size of the volume group? It's 10 gigabyte, right? Since it's going to be the sum of all physical volumes, right? So this volume group is 10 gigabyte, right? And make sure I get this right here. 8, 9, 10. Okay, cool. So we have 10 gigabytes. So this physical volume group, remember, is the bag that contains multiple physical volumes. It's 10 gigabyte. And again, it might not make sense as right now, but we're gonna get into the command line and actually do this for real, right? So now we grouped multiple partitions, or we grouped multiple hard disk into a bag called volume group. So meaning we can come here and take this, this, and this. See? Three different partitions from two different disks and put them in something called a volume group. So that volume group is kind of like creating a brand new disk. All you're doing really is you playing around with the size, with storage size. You see what I'm saying? So if this partition alone, for example, wasn't enough, and this partition alone wasn't enough, and this partition alone wasn't enough for what you want to do, you can just have them grouped into something called a volume group. That's pretty much why LVM is so important to understand, right? So meaning them by themselves, as you can see, they were just a bunch of 2 gigabytes, but you need to assign 8 gigabyte on the home directory, for example. But they're all 2 gigabytes. So that's why you create a volume group to group them here. So you have a disk now that is a virtual disk, but pretty much you have 10 gigabyte of space that you can work with. Now, you don't assign a volume group to a mount. So if you wanted to assign 8 gigabyte to the home directory, for example, you still have one more thing to do. So now that you have grouped them here and made it a 10 gigabyte virtual machine, you need to create, not virtual machines, you made a 10 gigabyte group, not actually virtual disk. The virtual disk is actually what we're about to, is actually the next step here. And it's actually what is going to be the thing that you're going to assign to that mount. And that is called the logical volume. So we have now space of 10 gigabyte. Great, because these were just a bunch of 2222 gigabytes. Now we have 10 gigabyte spaced into something that we call volume group. We now say, okay, you know what? We want to assign the full 10 gigabytes, or let's just say we just want to assign 8 gigabyte. Let's say yes, we just want to assign 10 gigabytes to the home directory, right? We want to assign 8 gigabytes to the home directory. That was our goal. You don't assign the volume group there. No, the volume group just helps you to group whatever amount of storage by grouping whatever amount of partitions, right? Now you need to, like, cutting a piece of this. Hey, since we have 10 gigabyte, I want 8 gigabyte out of this 10 gigabyte. Okay, cool. And that piece that you're cutting from the volume group is called logical volume. You see what I'm saying? And that's the thing that becomes the new disk. It becomes a new disk, so it's a virtual disk, which is pretty much, you were pretty much playing around with the storage of the disk, right? You now have a new disk that you can assign to whatever part of your computer. And let's go do that real quick on the command line, right? So remember, three things. We need to create a physical group, create a volume physical group, assign the partitions or the disk to that physical group, and actually no, you need to assign partitions to that group, not the disk. And then and because physical groups are there for the partitions, that's why you needed to create partition first, right? Remember, you don't assign the whole disk to a specific place. You assign a partition, right? So you don't assign this, you assign partitions, right? So 3 steps now. We need to create a physical volume, right? With the partition that we want to work with, and create as many, let's say for example, if you want to create a volume group of 3 partitions, how many physical volumes we create? We create 3 fuzzy physical volumes, right? And out of that volume group, right? Remember my explanations here, right? We create a logical volume, and that logical volume is going to be the virtual disk that we can now assign to a specific directory, right? Okay, so okay, let's say disk, let's go ahead and, so this partition here has 1.9 gigabyte, right? We need 7 more gigabytes to have 8 gigabytes, right? So let's go ahead and create another partition from another disk, for example, right? Another disk. So let's create a partition from this disk, right? And then create a volume group of those two partitions. So after we create a physical group for each, of course, and then create the virtual disk, which is the logical group of 8 gigabytes, right? So let's go ahead and do this real quick. So F this. I'm gonna go a bit fast here because that's what I did earlier, so you should know this already. What was I trying to work with? I'm trying to work SV. There you go. Okay, I did this before, so I'm not gonna go through the explanations again. I'm gonna go a bit fast here. I'm creating the partitions. Oops. Up, I put the wrong. Okay. Test demo 2. File system XFS start. Remember one. We need how many from here? We need 7 gigabytes, so 7,000. And actually, let me put 7,002 megabyte that's been parted. Right. So you can do a print here. Okay, as you can see, it's been created. Great. So quit. Clear. Ls block. As you can see, I went ahead and created. Okay, you see 6.5. Anyway, that's gonna be, so if we create a volume group of these two, we're gonna have a 6 plus 1 is gonna be 7, and then plus this. So let's say about 8.4 gigabyte, right? So that's what we needed. We just need 8, right? So let's go ahead and create the volume group. Okay, so to create the volume group, you need to install the package called LVM2. That's how you do that. So yum install LVM2. Alright, to create volume groups, so basically to do LVM stuff, you need to install that package LVM2. Okay, so let's go ahead and create a physical volume for each of those drives, right? Partitions. So pv create. Okay, first partition we want to work with is this partition here of 6 gigabyte. So let's go, and the partition is xvdc1, right? Boom, successfully created. Great. Now let's go create physical volume for the dd1. dd1, boom, successfully created. Alright, so we created the physical volumes for each of them. Let's go and create a volume group that has those two physical volumes, right? The command is going to be vg create, and then let me so it's going to be vg create dash n to name the volume group. Actually, I think that's on the logical volume. Let me make sure I check my. Let me make sure I'm not giving you guys the wrong command here, because I always mess put them together, logical volume and physical group command. Right. So it's vg create, the name of the volume group. You can call it whatever you want, right? So test. You can call it test group, right? Test group, and then you put the partitions, or the logical volumes, the partitions that you want to be, that you want to be part of this physical volume, right? And by partitions also call physical volumes, pretty much. So let's put the list of how many partitions or how many physical volumes you want to put in this volume group, right? We're talking two. Okay, so we have this one here, and we have the dd1, right? Boom, successfully created. Great. So to kind of check the list of your stuff, you say VGS to see the list of the volume groups and information. Okay, says that you have one volume group called test group containing two physical volumes PV. There's no logical volume made out of this test volume group, and here's the size of it. So the size, the combination of the two physical volumes, right? Also called partitions in this case, right? 8.338 gigabyte, right? Boom. So now that we have that created, remember, we're trying to create a virtual disk, and that virtual disk is what's called the logical volume. And the logical volume is made out of the volume group, right? So in this case, this volume group is 8.38 gigabyte, right? We need the virtual disk, also called logical volume, to just be 8 gigabyte because that's what we want to assign to the home directory, right? So let's go ahead and create that logical volume, right? And the command is going to be lv actually lv create -n to give the name to this logical volume. Let's call this let's call this what? Let's call this test. Let's call this test drive, right? Test drive. Let's call it test drive. Actually, let's just call it test drive, and then -l, uppercase L, to specify the size that you want this logical volume or virtual disk to be, depending on the volume group that you're taking this from, you're creating this from, right? And of course, you can exceed the size of the volume group, right? Since you created it from it, right? So we just need 8 gigabyte, 8G. That's it. And 8G, and then you need to specify which volume group you're creating this logical volume from, right? Remember the name of that volume group. You say test a group. Hopefully that's how I spelled it. There you go, it's been created. So let's do VGS to see the list of volume groups. We have one volume group called test group that contains two physical volume, and it contains one logical volume, and here's the size of it. Okay, now let's do ls block. There you go. You see this? Aha, it wasn't here before, right? And what do you see here? This, what, you remember this name? Test group? They added another dash here, but this is what? The name of the volume group, and what? The name of the logical volume, which is also the virtual disk that we just created. And what's the size? 8 gigabyte. It even tells you here LVM. This is the type, logical volume management, in some kind of way. That's what you need to really understand LVM. We could have attached we could have mounted the partition alone, but the concept of LVM is very important to understand because it helps you to play around with the storage, the size, it's, instead of, if this didn't have enough without the LVM system, how would you assign, you see how I'm playing around with two partitions from two different disks to create a new disk. You see, here's that same disk here. So this here pretty much tells you, hey, this partition is assigned to a logical volume. This partition is assigned to a logical volume, and based on the name, these two partitions are assigned or are being used by the same logical volume, right? And it shows you the size, and as you can see, it's the sum of these two. All right, so now let's say df-h. As you can see, the home directory, so /home, is not listed here, meaning the home directory is not mounted. It doesn't have any, disk mounted on it, right? So let's go ahead and mount that virtual disk that we created on that on the home directory. Okay, so before we do that, we need to apply a file system to our logical volume. We applied file systems earlier to each partitions, but now this logical volume is an actual disk. It's just virtual. So we need to apply it to it, right? Okay, give me 1 second here. Okay, so we need to do that. So how do you see the path? So remember, f disk dash L. I like f disk dash L because it shows you the path. Because when you want to work on this, doing the partition and stuff like that, you need this path, right? It's always going to start with def and forward slash in the name of the partition, right? But see here, remember earlier I did 1, 2, so this one here with 4 partitions, 2 with 1 partition, and then 3, and then 4. But boom, look, there's a 5th one. Where does this come from? Aha, you see the size? So as you can see, the logical volume presents itself as if it was an actual hard drive, because it actually is, but it's just a virtual one. You see what I'm saying? And as you can see, our hard drive, if I can call it like that, does not have a partition table set to it. That's why if you do mount, right, if you just go straight and try to mount that virtual disk to anything, it's not going to work. It's going to tell you file system is missing. So let's go ahead and actually put the file system onto it. So let me copy the path. Copy. Okay, so here's the command, right? mkfs dot xfs, right? And then there you go, mkfs dot fsz, and you put the path, right? There you go. Boom. And you could have done that to a partition too if that's what you were trying to do, right? Okay, now that we have it there, let's go ahead and do it. Let's say mount this. So mount this disk, right, or this virtual disk to this part of this computer, which is the home directory. Boom. Uh-oh, no error messages. So how do we know that it's been mounted? How do we see all the mount points and and stuff on the on the on server, right? It's df-h. Oh, look who just got added to the list. This wasn't here earlier. There you go. So this, aha, so with the size of 8 gigabyte, and currently 90 megabytes has been used, meaning there was something in here that is 90 megabyte. It's mounted on what? It's mounted on this. Let me clear this. ls plug. Do you see this now? Do you see? So, as you know, that for example, df-h is saying that it's currently using 90 megabyte, right? So let me go ahead and create something in the home directory. Let me say touch testing. Boom. Let me do df-h once again. Oh, it wasn't much to change anyway. Let me do something. Let me curl this. I want to add something there so you can see the size of the thing changing. Okay. Okay. Oh no. What am I doing? That's not what I wanted to do. Actually, is it even gonna work? Okay. Of course, it's not gonna work like that. That's not how you do it. Direct here. There you go. I redirected the cat testing, as you can see. Okay, so then diff, that should show some data. Oh, still looking in, so it's probably less than 1 megabyte still, but anyway, so there you go. you just did something amazing. What did you learn so far? You pretty much learned what disk management was. You learned what LVM was. You learn how to create a partition. You learn how to create a volume group, how to create a physical volume, and create a logical volume, and you learn how to mount a disk, or yeah, a disk to a specific part of your server. But last but not least, something very important to know if we're talking about disk management, and you definitely need to know this area here. Very, very important. There's a specific file on your server where all these disk management and size and yeah, where it's pretty much configured. And whenever you do this, yes, the mounting has been done, but you want to completely make it official, right? You need to go to that file and edit that file and put it there. That's how it's actually going to be completely official. Sometimes when you do the parted command, it even tells you, hey, you might need to edit that file. And how do you get to that file? The path to that file is a vi /etc fs tab. Very important thing to know. Fs tab. Come in here. I don't like, I like when it has colors. So let me install the Vim. Actually, I could have made the colors come in without Vim, or maybe not. Anyway, um, just like that Vim, I just like the fact that Vim does it manually. So let's see, FS tab. There you go. So as you can see, here is pretty much where everything that is mounted on is being listed here. And instead of putting the path to the drive, they put the, you remember that identifier that I showed you earlier, right? When we did the fdisk-l, this is the identifier here. So the ID of each drives. We can actually do that, but instead of doing that, we're just going to put the path to the drive, right? So apparently, according to this drive, so with ID, is mounted on disk, and this is the file system, right? You remember? And you always put default, and then 0, 0, right? And same thing here on boot, and here it is right here. You know, here they're even set the permissions here, and yeah. So let's go ahead and do the same. So I'm pretty sure there's a command to skip this. Anyway, so oh, man, I took the. So let's do f disk-l and see, get the path here. There you go. There you go. There you go. So we say this drive is mounted on this thing, and file system is this thing, and then we put default with s, and then we say 0, so it's 0. There you go. And then you save it. There you go. So guys, thank you for being here. I honestly, I did not expect this video to be this long, to be honest. But yeah, and if you have any questions, you know how to reach out to me. If you're watching this video on YouTube, reach out to me on this email, right? panelmaster21@icloud.com, right? All right. So happy learning, and see you.